So in section 2.1 we looked at direct variation. Now what we're going to do is we're going to take a look at inverse variation. They operate very, very similar to each other, as you'll find out here as we kind of go through this section. To begin with, the definition of an inverse variation function is a function that is described by the formula that looks like this right here: y equals k over x to the n. Now, once again, just like with direct variation, k cannot be equal to 0 and n has to be greater than 0. When we talk about k, we're talking about it being the constant of variation. Okay, highlight that, constant of variation. And then also we want to think about it in terms of words. So once again, just like we did last section, being able to move between the words and the equation is going to be important. So in words we would say y varies inversely as x to the n power, or y is inversely proportional to x to the n. Okay, so that's how we think about it in words. Now, what makes this different than direct variation: in direct variation they both went the same direction. In other words, if one went up, the other one went up in terms of our independent and dependent variable. Well, with inverse variation they're going to be going in opposite directions. So if the independent variable is increasing, well then the dependent variable is decreasing, and vice versa. So we want to think about kind of how that works in terms of the relationship between those two variables. Now, if we're given the formula t equals 48 over w, and t varies inversely as w, if n is equal to 1, then k is equal to 48. So we would say then that 48 is our constant of variation. So notice how that constant of variation is on the top of that equation, just like it is over here. Okay. We would also say that w is our independent variable and t is our dependent variable. All right, let's take a look at example 1 here. It says the number of units u in a length varies inversely with the length L of the unit. Write an equation that expresses this relationship. Well, there's two variables again. U is our dependent variable and L is our independent variable. So what we're going to do is we're going to say we're trying to write it in that same form that we had for inverse variation. So it's going to be U equals our constant of variation on top, which we don't know what that is, so we're just going to put k there, and then our independent variable on bottom. Now, there's no power on that because it's really to the first power. Unless they give us something else about a power, it would be to the first power for that. So in the second example, what we want to do is we want to go through those 4 steps that we learned in section 2.1 to kind of do this complete problem. And in this problem we're referring to the information from page 80 in your textbook, where we talked about the law of levers. And we know that from the information that was given to us that the general equation that we're working with is d equals k over w. Okay, so it says that Ashley and Sam are trying to balance a seesaw. Suppose Sam weighs 34 kilograms. Remember, W is your weight. So Sam weighs 34 kilograms and he's 1.8 meters from the pivot. Okay, Ashley is 38 kilograms. How far from the pivot should she be? Okay, so this is one of those examples where we're just going to walk through those 4 steps, and I'm going to kind of do that right here on the sheet. So the first thing we want to do is write our general variation equation. Well, nice for them, they gave us that information, so we already know what that general variation equation is. Okay, now what we want to do is we want to substitute in for our values of d and w to find k. Well, we have a ordered pair of w and d, and that was given to us with Sam's information. We know Sam was 34 kilograms and he was 1.8 meters from that pivot, so I'm going to say 1.8 is equal to the constant of variation over the weight, which is 34. Now what we're going to do is we're going to solve for k by multiplying both sides by 34. Now if we do that on our calculator, we should find that k is equal to 61.2. Okay? So that was what we wanted to do for step 2. Step 3 is to, whoops, I'm sorry, I did all of that information up here when I should have done it down here. So what I'm going to do is I'm going to go like this, and I'm just going to pull it down here, so I'm kind of cheating a little bit. So there's my value for k. Now what I want to do is I want to use that in the formula. So I'm going to rewrite this formula up here with this k value in there. So I'm going to say d is equal to 61.2 over w. And then finally I want to do what the question asked me to do, and that was we wanted to figure out how far Ashley should be if she weighs 38 kilograms. So I'm going to put 38 in for w and solve for d. So I'm going to say d is equal to 61.2 divided by 38. Now if I go ahead and do that on my calculator, we're going to get kind of an ugly decimal there. Ooh, that got a little bit weird. Let's try that again. So it's going to be about 1.61. Okay? So to finish up this section, I'd like to take a look at this third example, which comes from page 82 in your textbook, and it has to do with the intensity of light and the distance from the light source. So here's what we have in words. The intensity of light is inversely proportional to the square of the distance from the light source. Okay, so now we have something we haven't had yet, and that's the idea of something other than to the first power. So we have the square of the distance. Well, if I write that out from words as an equation, this is what it's going to look like. I equals k divided by d squared. So now we want to kind of go through those 4 steps and find out, well, based on the information we're given, okay, about 6 meters from the light source and having a light value or source of 30 lumens, we want to go ahead and see if we can figure out, well, what would the intensity be if it's 9 meters from the source? Okay. Well, we're going to go through that same 4-step process. So we already have our general equation. Now we're going to plug in what we know. Well, we know when it's 6 meters from the source, it's 30 lumens. So I'm going to say 30 is equal to k over 6 squared. In other words, 30 is equal to k over 36. And then I'm going to multiply both sides by 36 to get my value of k, which is equal to 1080 if we go to our calculator on that. Okay? So that means that our k value, our constant of variation, is 1080. So now what I'm going to do is I'm going to rewrite my equation with that value in for k. So I'm going to say I is equal to 1080 over d squared. And now I'm going to do the last step. So the last step is to plug in my 9 for d and solve for I. So I can say I is equal to 1080 divided by 9 squared. I is equal to 1080 divided by 81, and then you can go ahead and go to your calculator to get that value, which is approximately 13 1/3. So that means it would be about 13 1/3 lumens for its intensity. All right.